Hello everyone. This video will show the basic definition of a limit. Before we go over this definition right here, let's go over this given notation down here. So this notation that we have here is read as the limit as x approaches a of f of x is equal to L. Now let's jump right into the definition of a limit. Given a function f, so we have a function f right here, and a fixed number a. If there exists a unique value L as x approaches a either from left or from the right, f of x approaches L, then the limit exists. So this definition is telling us that as x approaches towards a either from the left or from the right, f of x approaches towards L. Then we go ahead and say that the limit is equal to L. Now, what happens if they don't apparently end up the same value? So given this function right here, if x approaches a from both left and right, and the function takes a different value, in this case right here, we have two values, then the limit of f of x as x approaches a does not exist, which is given an acronym DNE. So the other way to say this is that if we trace the graph from left and from the right, trace the graph, and they apparently end up at a different value. In this case, the one coming from the left end up on L, and the one coming from the right end up on M. Since they don't apparently end up at the same value, then the limit does not exist. Now let's look at this definition in a different perspective. Before we go over this definition right here, this notation that we have here is read as the limit as x approaches a from the right of f of x is equal to the limit of x as it approaches a from the left side of f of x. Now let's go over this definition. It says that the limit of a function at x equals a can be determined by evaluating the limit from each side. So it's pretty much the same thing. If the limit as x approaches a from the right side and the limit as x approaches a from the left side are equal, so it's pretty much telling us that if they are heading towards the same value, which in this case here, the same value which we can write as L, then the limit exists. Now what about if they don't apparently end up the same value? So if we trace the graph from right and from the left, and they apparently end up at a different value, in this case, we can go ahead and say that this is equal to M and this is equal to L. Then the limit as x approaches a of f of x does not exist, which is given this acronym DNE. So that is the basic definition of a limit.